Hello, good morning students, and welcome back once again to another video for the class 10th light chapter. So in the previous video we studied a few numericals, and let's continue with them to get the further idea of how mirror formula and mirror formula and height formula works. So the first question for today is, an object of height 3 cm is placed in front of a concave mirror. So first of all, like I said, always draw a rough ray diagram so that you have an idea. So this is our concave mirror, and the object of height 3 cm is placed in front of the mirror. Now let's further read the question before putting the object in the diagram. At distance of 5 cm from the mirror, if the focal length of the mirror is 4 cm and the image is formed at 20 cm in front of the mirror, find magnification. So you are supposed to find the magnification. So over here the concave mirror is placed and the focal length is 4 cm. So we have focal length 4 cm. So this is our point of focus. And the object is placed at 5 cm. So let's say that the object of height 3 cm is placed at 5 cm over here. So I am writing 5 cm. Okay. But the image is formed at 20 cm in front of the mirror. It is said. That means the image is somewhere over here. So we know that in a concave mirror, whenever the image is formed in front of the mirror, it is always inverted. So we have placed the image over here. Now this is 4 cm the focal length. So the radius of curvature will be 8 cm, like this. So the radius of curvature is 8 cm because radius of curvature is double the size of focal length. So over here at 8 cm mark, we have our center of curvature. So as you can see, the object is between F and C, so the image is formed beyond C, and so it is enlarged. We know all the cases. That is why I know this. So obviously the magnification will be greater than 1. So whenever I find the magnification, it will be greater than 1. So that should be our answer. Now because the image is inverted, the magnification will be negative also. So whenever we get the magnification as negative, it means that the image is inverted, and if the value is greater than 1, that means it is enlarged. So the image has been enlarged. So it's quite simple. To find the magnification, we have the formula minus V upon U. Okay, so time to place the values. Over here V is given as 20 centimeters, but as we know that it is 20 centimeters in front of the concave mirror, that is on the left hand side of our pole, and therefore the V will be taken as minus 20, correct? And U, this is our object distance, that is 5 centimeters given in front of the mirror. So we have 5 centimeters over here as well, but once again, because it is in front of the mirror, we always keep as negative. Okay, now you get this two negative signs which can be removed, and 5 4s is 20 and minus 4. So your answer is minus 4. So as you can see, this minus sign indicates that the image is inverted, and this 4 indicates that it is enlarged, quite enlarged. It is greater than 1. So the magnification is minus 4. Now in this formula, although it is not given, I want to show you that you can find the height of the image as well, how much larger it will be. So let's say that we have another formula, magnification is equal to h dash upon h, that is the image distance upon object distance, and this is what we need to find, image distance h dash. The height of the object has been given, that is 3 centimeters. So you can place that 3 centimeter over here, and the magnification you just found, which can be placed over here in this formula. So let's say that magnification is minus 4, and we have h dash upon 3. So simple cross multiplication. So over here you get minus 4 into 3 equals h dash. Therefore h dash is 4 3s 12, minus 12 centimeters. So this is the height of the image. So the image will be quite enlarged, 12 centimeters, because the object height is just 3 centimeters, and the image h dash will be minus 12 centimeters. So you can see that minus sign indicates that it is in the opposite direction on the negative y-axis. So if you know all the cases, whatever we studied in the previous videos, the image formation of the concave mirror, then this solution of the numericals will become much easier, because at every single step you can question whether the answer is correct or not. If you have the inverted image, the height of the object should be negative, magnification should be negative. Okay, if the magnification comes as positive, that means you are wrong. So over here, let's say that you forget to put minus 20 over here because the formula already has a minus sign, and you just put 20 over here and you forget to put minus 20, then negative negative will be cancelled. So 5 4s 20. So what you get the answer, the magnification as plus 4, which is wrong, because plus 4 means it is erect image, and that can only be formed behind the mirror in the case of concave mirror, and that is not possible, because to form this kind of image the object should be placed after the focus point, that is between focus point and the pole. So hence this case is not valid. So that is how you can check all the cases. Okay. Similarly, I have another numerical for you, and this one is quite longer, so it will take a lot of time, so please bear with me. Okay. The question states that an object of height 2 cm is placed in front of a concave mirror. An object of height 2 cm is placed in front of a concave mirror having focal length 15 cm. So we have a concave mirror like this, okay, and its focal length is 15 centimeters. Okay, at a distance of 30 centimeters. Okay, so the object is placed at a distance of 30 centimeters. So 15 and double 30. So the object which is having height only 2 centimeters is placed at a distance of 30 centimeters from the mirror. So this is 30 centimeters U. So U has been given to you, and this is focus point F. So therefore this is your focal length 15 centimeters. Okay. Find the image distance, image height, magnification and nature of the image. Okay, so you are supposed to find everything in this case, and this type of numericals are asked in the examinations for 4 to 5 marks. Okay, so this type of numericals are really very important, so please pay attention carefully. So the object height has been given. Write all the values first of all. So U, that is the object distance, so it is 30 centimeters, so we write minus 30 centimeters. V you are supposed to find. H, height has been given to you. H is 2 centimeters, and obviously in positive because it is placed on the top of the principal axis. Okay, so the height is 2 centimeters. Focal length has been given to you 15 centimeters, but because this is a concave mirror, focal length is negative, so you write negative 15 centimeters. Now in this case, find the image distance. First question. So you are supposed to use the mirror formula, and that is 1 upon F equals 1 upon V plus 1 upon U. We studied this formula and we found the image distance for a convex mirror in the previous video. If you remember, that was quite simple. Now because this is a concave mirror, it is going to make things a little bit more complicated. So 1 upon F, that is given to you, focal length, so write minus 15 centimeters. 1 upon V you are supposed to find, and 1 upon U is given as minus 30 centimeters. Okay, now because this is positive and negative, this will become negative over here, so you get minus 15 is equal to 1 upon V minus 1 upon 30. Okay, minus 1 upon 30 goes on this side, becomes plus 1 upon 30, minus 1 upon 15, okay, plus 1 upon 30 equals 1 upon V. Now you know that this particular thing we have to find now LCM. So 15 2s 30 and 2 multiply on top as well to make the LCM similar. So what you get is minus 2, this minus sign can be taken on top, minus 2 plus 1 upon 30 equals 1 upon V. Okay, very simple. And 2 minus 1 is 1, but the negative sign, so we get minus 1 upon 30 equals 1 upon V. Therefore, we take the reciprocal of this. 1 upon V is equal to minus 1 upon 30, and therefore V is equal to minus 30. We take the reciprocal of V, so therefore we take the reciprocal of 30 as well, but the negative sign remains, so you get minus 30 over here. So what do you get from this particular answer? We have now V as minus 30 centimeters. So if focal length is 15 centimeters, then the radius of curvature R is also 30 centimeters, because now this object is placed on center of curvature. So if you take your table that I have taught to you and you open your textbook, you will see that if the object is placed on center of curvature, image is also formed on center of curvature, and it is of the same size and same height. Okay, so that is why we have the image distance also as minus 30 centimeter, because if the object is placed on center of curvature, image is also formed on center of curvature, which has been just proved to you in this numerical. Okay, so your answer is same as the radius of curvature. Understood? Moving on, now you need to find the height. Because this is on center of curvature, the height should be same as the object. So what is the height? Height is 2 centimeters. Okay, so height should remain the same. But in order to find the height, first of all you will need to find the magnification. And in order to find the magnification, you will have to write that magnification m is equal to minus v upon u. And as you know that v is minus 30, so I am writing minus of minus 30 upon u, that is minus 30 centimeters. So minus and minus get cancelled, 30 ones. So what you get? Minus and 1, so you get minus 1 magnification. So like I taught you in the class that if the magnification is 1, that means there is no enlarged image. If the magnification is less than 1, image is diminished. If the magnification is more than 1, it is enlarged. But in this case, you can see that magnification is 1, and the minus sign indicates that it is inverted. Okay, so magnification is 1, that means not an enlarged or diminished image. Not an enlarged or diminished image. So the image is neither enlarged nor diminished. It has remained the same. So the height and the size is same. The only difference is that the image has been inverted. Okay, students. Now for the next part, that is finding the image height. So you know that magnification m is equal to h dash upon h, and that has been given to you, that magnification is minus 1, h dash you need to find, and h is 2 centimeters. Just substitute the values. So what you get over here is magnification as minus 1 is equal to h dash upon h, that is 2 centimeters. Simple cross multiplication, it becomes minus 1 into 2 equals h dash. Okay, and therefore h dash is equal to 2 into 1 is 2 and minus 1. So minus 2, so you get minus 2 centimeters as the height. Once again you can see that the height of the image is also the same as 2 centimeters, but the negative sign over here indicates that it is just inverted. Okay students, so we found the image distance, we found the image height, we found the magnification, and the last thing remaining is nature of the image. Now what do you understand by the nature? The nature of the image means what type of image it is, whether it is virtual or real. In this case, the image is formed in front of the concave mirror. So you know that as long as the the image is not inside the mirror or behind the mirror, that means it is not virtual image. So in this case, the image is in front of the mirror, and therefore it can be projected on the screen, and hence it is a real image. So the last thing that you need to write, that the nature of the image is real. Okay, or you can write the image is a real image. That is what the statement you need to write in order to get the mark, because that particular statement also has half mark or 1 mark depending on the question paper designer, okay, and how the answer sheet works or answer key is given. This is how the whole numerical works. Okay students, till then, have a nice day.